Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. In this episode, we talk with Nigel Cannings about deepfakes. Or do we? Is it even us? Are you even you? So while you enjoy that existential crisis, let's get on with the show. Nigel Cannings is the CTO of Intelligent Voice and the CEO at Metahuman. He has over 25 years' experience in both law and technology. He's the founder of Intelligent Voice Limited and the pioneer in all things voice. Nigel is also a regular speaker at industry events, not limited to NVIDIA, IBM, HPE, and AI financial summits. And now he can add to that list that he's been a guest on The Cynical Developer. So welcome to The Cynical Developer, Nigel.
Well, thanks very much, James. And I think I'm going to put The Cynical Developer first on my playlist there rather than last. I mean, it's without question the most auspicious of any event that I've spoken at. So thanks very much for having me.
Not a problem. I have been told this by many guests. Do feel privileged to be on.
I do indeed. But that's my deep fake talking, obviously, not me.
Right. Sure. Yeah. So we'll have to put a disclaimer at the end of this that anything that was said or wasn't said or may have been said may or may not have been said by either of us or none of us.
Who knows?
Yeah. So before we go too far into the jokes of it being us or not being us, for those of the listeners that don't know what a deepfake is, could you give us a quick overview? What is a deepfake?
Yeah, sure. I mean, it's a way of recreating audio and video images, effectively pretending to be someone else. I mean, so a lot of people will have recently seen a video of Tom Cruise purporting to play golf. And, so Tom Cruise was there. He came up to the camera. You saw him moving. You saw him playing golf. It wasn't Tom Cruise. You may well have seen videos of Barack Obama talking and giving a public service announcement. It wasn't him talking. And, that is a deep fake. So, and actually, one or two of your listeners might have actually seen images which purport to be famous actresses involved in pornographic movies who aren't. And actually, if we're perfectly honest, that is where the majority of deep fakes have been seen. But yeah, it's a way of effectively mimicking the audio or video of an individual and making it appear to be them even when it's not.
Yeah, it's like photoshopping for video and audio.
Yeah, absolutely. But done, in a very, very realistic style.
Yes, yeah, and I think my very limited knowledge on this is that there's a couple of different ways that this is done, because I know that there's an application on my mobile phone. I think it's called Face App, and they take a photograph and they stretch it over a very low res sort of polygon 3D model that's been put over the top of a video. And try and fit your face to it, I think. And that's one of them. But they're very, very easy to see that they're not real.
Yeah, absolutely. I mean, the whole thing started about 2014, actually, originally, the kind of technology that underpins it. Because if you go back further than that, what you see is people trying to take real audio or real video and trying to kind of replay it in situ. So imagine like those kind of blackmail notes that you see from newspapers. People have cut bits out of newspapers saying, pay me £50,000 or the puppy gets it type of thing. Yeah. Well, the audio, deep fake audio before deep learning, which is where the whole deep bit comes of fakery. It was, you spliced bits of audio together and then you replayed it to make it sound like it was the person. So you took little bits from different speeches or whatever, and you did it like that. And doing that with video is a little bit more difficult, but there were, almost animation type techniques that people used to try and make it look like there was a person. And you go back to things like Tron. I don't remember Tron. I'm old enough to remember the original Tron, not
Yep.
the remake.
Yeah.
And I'm being amazed by the CGI that came out of that in kind of whenever it was, 82 or 83, something like that. So using CGI type effects to try and mimic people. But it was actually in 2014 the idea of something called a generative adversarial network was born, and it was a new type of neural network, which, rather than just being trained from data, and again, most of your listeners will know that the way neural networking works, the way today's deep learning works, is basically you've got a big pile of data, say images, and you've got a label attached to that image. So it says, this is a cat, this is a dog, this is a horse, this is a zebra. And you feed all of that into the neural network, and the neural network learns from that. And that can take millions of images, or if it were audio, tens of thousands of hours of audio to do that. But some bright spark doing his PhD at the University of Montreal came up with something called a generative adversarial network. And basically, it was a way of making two neural networks fight each other and learn from each other effectively, using what's called an actor-critic method. So effectively, one network tries to fool the other. So what you need is a very small amount of true data to actually validate what's been said, and they just kind of fight each other. And one of the things that came out of that was an idea of doing styling or image transfer. So a lot of what we saw originally was things like, here is a picture which has been done by Monet, make it look like it was done by Van Gogh, and you'd do this style transfer, and it just turned out these generative adversarial networks were brilliant at this, just absolutely brilliant at it. And of course, inevitably, what that meant is someone thought, is there a way we can generate other fake things? So there was a whole load of fake Japanese anime stuff came out. But it was really, that moved on quite quickly into kind of 2016, 2017, of actually applying that to video. And to use that idea of so really in video terms, deepfake video is about style transfer of the face. So where you're effectively saying, I take the features that I see of the face and I can map another face onto it. And that's one of the reasons it looks so realistic, but it is being done effectively on a real face. So when you see in these videos someone moving around and the eyes blinking and the mouth moving, there's actually someone else's head under there who is animating that. And that's the thing about deepfake videos, is that it's actually the animation is actually really being done by a real person, with your face kind of in kind of Hannibal Lecter style being kind of overlaid on top of it, and kind of stuck on the top. Whereas deepfake audio is actually quite different in the way that it's being used. So deepfake audio is a much more generative type of process. And what you're doing with that is you build a model which kind of produces generic voices. So there are things like Tachytron 2, which Google came out with, and Waveglow. These are things which are really good at producing highly realistic sounding voices, but not necessarily a voice that belongs to anyone. It's trained on generic audio, and it can produce very realistic sounding voices. What you do to deepfake it is you add what's called conditioning. So effectively, you use a small sample of someone else's data to say, well, if I make it sound a bit like this, if I adopt the features of this other person's voice, which might be pitch, tempo, variation in pitch, variation in the rate at which they speak, if I use conditioning on that generic voice, I can use quite a small amount of audio to actually make it sound like that other person. And so they're two quite different approaches, but you come to the same point, which is basically it's a really good way of fooling people into thinking that the thing that they're seeing or the thing that they're hearing is actually a real person and not someone else just spoofing them.
So is that done with the actor critic model then? Does the one process go, right, I'm going to try and make it sound like this set of sample data? And it goes, right, I think I've done it, sends it to the other AI, and that goes, no. And then goes, right, well, what about this? What about it? Until it gets it? Or does it just do it based off that one set of data and goes, I've got it first time?
No, so the actor critic stuff is really to design the base model for the particularly for the video stuff. It's really image related, but
Okay.
it's a bit like saying I I've created a $100 bill, and I'm kind of alive to this at the moment because I was listening to a podcast about North Korea earlier, and them the way they generated the super note, the idea of the $100 bill that no one could detect was a fake $100 bill. So the idea is, imagine that you've got the world's most expert counterfeit detector. And the idea is that the generator has to try and generate a $100 bill, which will fool the person who understands it more than anyone else in the world. And what they're doing is they start by using a crayon and drawing and writing 100 on a piece of paper. And then they hand that thing over to the critic, and he goes, "Ah, you fool! That's ridiculous." And then they use a green crayon next time because maybe green works, and they hand that over, and they go, "Ah, you're a fool. You're a tiny bit closer, but you're still a fool." And eventually, after 10 million iterations, eventually you produce something which passes the critic, and that way the generative network knows it's got it right. So it knows if it produces something in that style, it's beaten the critic, so therefore it must be right. So really, it's just a way of teaching it transformations.
Right. Okay.
And it's a way of teaching a network transformations. It's a massively computationally expensive way of doing it, because it's just basically, like I said, it's just starting with something random, until you eventually draw 100, and then you draw it in green, and then But
Yeah.
and that's why these models are generally built by people who've got unbelievable computational power. Nvidia did a great version of the Tachytron 2 model, but they have got access to more GPU cards and more processing power than any other company on the planet. And that's a whole other thing about how big tech has taken over neural networking and this stuff, because they're the only people who've got the processing power to do it.
Sure.
But once you've done that, lesser mortals such as you and I can then use what they've built and say, well, actually, I just need to add 5 minutes of data on the top to condition it to do what I need.
Okay. Okay. So how does the audio work then? Is that just because you give it the sample data to go off of, and it produces your voice?
Yeah. Yeah, it's kind of, I mean, the again, the audio thing is, the idea is you've built this kind of base model that's really good at generating generic other voices.
Mm-hmm.
So and then by adding in, and when it's generating that voice, it's doing it based on features. So it's not based on a recording, it's just based on features of the human voice. So things like pitch, things like latency, and the speed at which you react to things. And so if you give a sample of your voice, what you do is you break that sample down and you say, right, I now understand that Nigel speaks within this pitch range, and he speaks at this type of latency, and X, Y, and Z, and all these other features that we get from voice. And so I know that if I adapt my generic one to match that, what we loosely call a voice print, it's not a voice print, but kind of, I adapt the generic voice print for the Nigel voice print, I'll get something which sounds worryingly like Nigel.
Yeah.
And I've got an app on my phone. I was listening today where I made myself sound like Will Smith, Apparently, there's another app where Will Smith tries to make himself sound like Nigel Cannings, but that's less popular, apparently.
Yeah. There's a friend of mine who's got a business, and he's looking into voice stuff, and I know that he has something that you can dictate to, and it will generate your voice. So it's something that it's been on my to-do list, and as regular listeners to the show will know, my to-do list is so long that I'll probably never get around to doing it. But I wanted to create an episode that is, it sounds like it's me talking all the way through, and be one of those monologue episodes. Whereas, matter of fact, it's not. It's actually a generated voice, just reading the script that I wrote. And I think that the way that would benefit, it would probably be more realistic than, say, you had that data and you wrote a script for me to read in my generated voice, because I would probably write it the way I would speak. So it would use the terminology and the sentence structure the way that I would speak. So it'd be probably a little harder for people to detect than,
But you see,
if you did.
But you see, you've hit on the limitations to technology there. You see, what deepfake stuff is good at is shorter pieces of speech. What it's less good at is doing. You'd notice over a while that the intonation sounded kind of similar. So deepfakes are really good for things like speeches. So if you want to mimic, like the Barack Obama thing, Barack Obama generally sounds the same from the beginning to the end of every speech that he makes. But I guarantee you, when he used to sit over the dinner table having dinner with his kids and his wife, he sounded quite different. His dynamic range was different. The way he spoke to them, the pauses would be much more conversational. And so, and I did an experiment a while back using deep fake audio to do John Wayne, because John Wayne's a great one. I mean, it's really, there are many things people don't like about John Wayne, but by God, his voice is very distinctive. And the thing is, every one of them sounded just like John Wayne. But by what I mean about that was that kind of, that you, John Wayne, kind of, and I'm entirely sure that when, John Wayne sat down and chatted to his wife, wasn't saying, "Hey, wife, how's it going?" Kind of that kind of, he was probably just chatting away like the rest of us. So actually, to mimic you for a 40-minute long podcast, people who knew you would begin to think, "Do you know what? He's not sounding himself today. He's really not."
Yeah.
Because actually getting the pauses in the right place, the laughter, the humor. Because I tell you what, a deep fake audio does not understand irony. It really doesn't. If you or humor, or so if you you'd have to, and it is possible to introduce that, but literally in the text you'd have to kind of underline it with a mark saying, that was supposed to be funny,
Yeah.
and actually, so deep fake audio it's really great for spoofing people who don't know you very well, or who want to believe, or you're doing it for short sentences. But no, I would not.
Sure.
At the moment, it would begin to sound curiously robotic.
Yeah.
For a conversational type of podcast.
Yeah. It's quite funny, actually, that you talk about that it wouldn't sound like me. Now, we talked before we came on air that I've got this podcast. I've also co-host Tabs and Spaces podcast. I've got a YouTube channel, and I've run the Cynical Developer for 5 years, something like that now. And I've got a podcaster voice that I put on when I do this. I don't intend to do it, but it's how it comes across, and it's through the years of trying not to go and when I talk on here, it's a slower cadence to what I would do normally, because in the local area we talk quite quickly. So I try to slow it down a little bit, and I try not to go a lot. And then when I was doing the YouTube videos, I had a few people tune in and watch live Instagram videos. They were they were watching my YouTube, and they went, "It looks like you, but it doesn't sound like you." And I was like,
Exactly.
"Yeah, it's podcaster me coming out, and I'm trying to move away from that." And like the Tabs and Spaces podcast, it's a lot more laid back than this, because the idea on that show is that we're a group of people sat around in a pub just having a chat about technology, and it's a lot more laid back. It's a lot less formal. So the real me tends to come out a little bit more, whereas this is that little bit more formal. And because this has been my baby for so many years, it's hard to get away from that format.
Yeah.
But I'm trying now. Now we're back. Now technically it's a new season. I'm trying to make it a little bit more lighthearted, make me a little bit more me, and try and get away from that very stagnant, more professional shirt and tie type show.
But actually, and you've hit upon something really interesting there, because if this were being done with video only, then what I just said would not apply, because actually deep faking video is significantly easier than deep faking audio. Because if you think about it, whilst not quite two-dimensional, the range of expression and what can be done with a face is very limited compared to what can be done with a voice. And because I work in the speech processing world. I mean, it's what I've done for the last 12 years of my life. And people think, oh, speech recognition, that must be really easy, and I can say, hey Siri, and it will do stuff now. And yeah, sometimes it will, sometimes it won't. But there's massive variation in the human voice. Yep. In the range we use, in how expressive it is. Even if I'm tired, it changes sound. If I'm emotional, it changes. If all of these things. Whereas the face, actually, the number of vectors you're using on the face to actually map it is actually very limited. You don't need a lot. A few bits on the forehead, you need a nose, around the eyes, kind of top of the cheekbones, the rest of it. But to map a face, there's probably 100, 120 points you need to map. In the human voice, there's more than 120 features you have to map in 10 milliseconds, just in that one tiny slice, let alone over, you multiply that up to an hour. That's a lot of milliseconds. That's a lot of slices you have to do. So the human voice is actually incredibly difficult to map realistically for a long period of time, but unbelievably easy to map realistically for a short period of time. And that actually is I think the danger that we're beginning to face with deepfake, not the video. I think unfortunately that race has pretty much been won now. It is possible to detect deepfake video, but not for most ordinary people. But deepfake audio is the one that you actually believe someone when they talk. If you hear someone talk, if I read something, I might think, well, it's possible that could have been faked. But if I hear someone say it, and there's a couple of years ago, there was there's a UK company scammed out of about $250,000 because the CEO of this UK subsidiary got a phone call from his boss in Germany saying, I need you to pay a Hungarian supplier in the next hour. Here's the details. And he's like, that's my boss. And he told me to pay $250,000. So he paid it immediately without thinking. Well, it wasn't his boss. It was deepfake audio. And the only reason we know this because their insurance company, they paid out and then they told people to watch out for this. But it was convincing enough. Yeah, in the same way that people are getting WhatsApp messages at the moment or email. We get loads of them at work from saying, so my business partner for some reason people think he's more important than I am. So all the fake emails come from him, and it says, dear name of employee, I'm in a meeting at the moment and I need you to contact me urgently. Send me your address so I can WhatsApp you. Kind regards, Ben. And we had one person do it. We actually had one person fall for it. That was in email. So imagine if Ben, who has a very lovely voice, were to phone them up and say, "It's Ben here. It's an emergency." And there have been instances of people using this to try and get money out of, pretending that someone is abroad and, it's dad, and normally it's someone doing it in a very bad accent, but it would be quite easy for you and I, for example. So, you and I both have our voices out there on the internet somewhere for someone to generate. And I'm not advocating this to any criminal who might be listening, by the way.
Don't pick on me.
Under no circumstances, pick him, not me. All right, just so we're clear here. It was his idea to come on the podcast and talk about this, not mine, I promise. No, but our
got
voices,
the audio to prove that as well.
Exactly. Our voices could be cloned, and if someone knew our home phone number, which is not difficult to find out, and they knew we weren't there, which if I speak back when we used to have air travel, I used to speak at events around the world and that type of stuff, so it was pretty obvious that I was somewhere else. And my wife got a call saying, I'm distressed, I need some money, can you just send me, I just need a Google Play voucher, just get me, because that would be the simplest thing to cash. It's $200. What's she going to do? She might try and phone me, but it's probably the middle of the night, and because it's the middle of the night, my phone will be off. And bear in mind that scammers are fairly sophisticated, so they will, and it's a numbers game. And is someone going to scam me for a couple of $100? Actually, people are doing it all the time. We know this. And robot calls going out. How many people get robot calls at the moment saying, I've had about 4 this week saying that my I'm trying to think what it is. A criminal notice has been placed against my national insurance number or something like that. And it's a criminal notice has been, it's like, it's like, I'll be back, it's a real Terminator style thing.
Yeah.
But imagine if it was someone I trusted, or someone who sounded quite convincing, maybe it's Joanna Lumley, I don't know. But someone who were to phone up and say something to me. And this is the real problem, is that for short sentences, easy things, which are declarative and don't require a lot of interaction, deepfake audio is going to really begin to become a problem for fraud.
Yeah, I definitely wasn't concerned about it until about 2 minutes ago. And now it's a case of, actually, there is quite a lot of possibility, because I've had friends who've had their social medias accounts compromised, and had message from them saying, I'm in such and such a place, I'm stuck, I need money now. And I've been able to look at it and go, well, it's not you. 1, you don't write like that. 2, I know you're on the bones of your backside, so you couldn't afford to be in that place in the first place. So it's definitely not you. And then I'll ring them and go, look, your account's been hacked. But if it was a close friend who had rung me, or in whatever way, telephone call or WhatsApp or other platforms are available, then that's a different story, because I could have gone, yeah, sure, here's some money, until they wanted me to wire it to them with Western, whatever it's called.
I was thinking Western Digital, but it's not, is it?
Yeah, no. I was going to say Western Digital.
Yeah, exactly. it's the Express thing. God, we're going to sound like a pair of idiots after this, aren't we? It's something Express, something's not Fed. Yeah, it's Western. Do you know what? We should move on and come back to that particular one, shouldn't we?
Yeah, if we don't draw attention to it, no one will notice.
Absolutely, it'll come out in the edit. It'll be fine. They'll never notice it, which is great.
Hopefully.
So that's brilliant.
Yeah.
But yeah, it's and it works in the other direction as well. So imagine if, and again, not wishing to give too much away to people here, but your voice is out there, and how many banks would your fraudster have to phone with your fake voice until they got your bank? And unfortunately, and I do really say unfortunately, that many banks now are relying very heavily on voice biometrics as a way of doing authentication. So a certain well-known bank who, if you were to Google "my voice is my password" and "stupid bank," you would find that a number of years ago actually said that "my voice is my password," and they sold this. And so two BBC journalists phoned up, and they were non-identical twins. They weren't even identical twins. And one phoned up pretending to be the other and went through the voice biometric protocol. So where you just speak and you get asked questions, and passed, and was able to access, using simple questions, which would be easy to find out, were able to get into the account.
Yeah. Well, that sort of comes full circle back to you saying about the different points on a face that you have to map and compare that to a voice. Now, I'm one of 5 kids, and the eldest of my younger brothers. At one point, we don't look that similar. If you stood us next to each other, at the time we didn't. We've both lost hair, and we've both got beards now, so we look a lot more similar. But he was able to log in to my Xbox account with his face through the Kinect, because of those simple points.
Yeah.
You sort of you think, oh well, I can understand how that's done because it's done on those simple points, and then you bring it to voice, and you think, well, that's got to be impossible, but then.
It's not.
No, it's not. It seems to be a lot easier.
Yeah. So and that's why. So some really simple tips. Say someone phones you up and pretends to be someone who you know, the first thing you have to do is ask them a question that only they could know the answer to. So I know it sounds I mean, it's obvious. I'm saying it. Anyone's listening to think, yeah, of course, that's the first thing I'd do. Well, you would now, but you wouldn't have done before, because you trust the voice. So, you say, where did we go for our first drink together? Or, one of the many things that we might ask of close friends that we wouldn't want revealed on a podcast. But, you ask them something like that because there may not be someone on the other end anyway, because it may be a one-way thing. It's like, all you're hearing is, and these sort of things are used in call centers for kind of human engineering and phishing type of stuff, where people play a crying baby in the background, like on a recording, to elicit sympathy. So it's that kind of one-way broadcast of emotion which overwhelms the person on the other end. But if there is someone, because increasingly these things become more sophisticated, so someone's actually able to type and generate the voice in real time. So you need to ask them a simple question that only they could answer, and that stops it dead. And that's kind of the way that banking and so on is working now. And this is a lot of the work that we do, is around, if you can defeat biometrics, and biometric systems have got better, but you can still defeat them. What are the other ways you can get around them? And there are things, asking questions is a really good one, because there's two sides to that. One of which is, a factual question has only one answer, right? And you either know the answer to it or you don't. So if you ask someone something sufficiently difficult, then they ought to be able to answer it. But actually, if you think about a bank, how many things are there which are so difficult that they can ask you that question that only you would know it, but you'd actually be able to answer? Well, you're not going to tell them anything personal. And a lot of the time they'll say things like, what did you spend 3 weeks ago, and where? And I'm always like, I haven't got a clue.
Yeah.
You know,
I've had the bank hang up on me because I couldn't tell them any of my direct debits and how much they were for.
exactly, how the hell am I supposed to? That's why I've got a direct debit. So I
Yeah.
don't need to know. You know,
Yeah.
why are you asking me this sort of stupid question? So you know, it's. But there are things you can do there. So if I ask you a factual question, I expect you to respond within a particular period of time. But that particular period of time is fairly unique to you. It's within a time range. But so if I ask you your name, you'll there'll be a short pause and you'll tell me. If I ask you date of birth, the same, and sometimes there's a slight variation, but it's within an acceptable bound. So if you're a fraudster ringing up with you're sitting there and you're a good typist, so you can type quickly, and I ask you what's your date of birth, then they're going to type. They've already got it there ready, and they hit a button, and it says, that response is absolutely critical to determining whether that is true or not. Because if it's too quick or if it's too slow, it indicates that in one way, shape, or form, you're being spoofed. So, because what's happening now as well is the deep fakery is actually moving into real time conditioning. So it won't be long before I could actually change my voice as we're speaking to someone completely different. So it's been done for video for a while. So when we had our Christmas Zoom drinks this year, one of our developers turned up firstly as Father Christmas, then as Harry Potter, and various other people, and his whole face changed in real time on the call. So, but you can now do that with voice. So I could sit with a headset and effectively change my voice to someone else. So actually, there's a real human there, but they're using someone else's voice.
Yeah.
So if I ask a factual question, I expect that factual question to be answered within a particular period of time. So when they ask you your name, they're going to know that because it's written down in front of them. But when you ask the date of birth, there'll be 29 whatever. There'll be a short pause there because actually they're having to use an element of stopping, looking, reading, and finding it out. And the more fact, what's your mother's maiden name? Well, they're going to be ready for that one. So they'll answer it so quickly that actually a real human wouldn't have done that. So real people answer real questions in a very particular way. They use certain types of latency. The tempo doesn't change a lot because when I ask you your name, you will tell me your name. You won't say it too quickly and you won't say it too slowly. You'll answer within a certain period of time. And someone who's spoofing you will not be able to mimic that same pattern of behavior that you can as a real human being. So that's one technique that is being used to try and detect whether the person who is speaking is actually who they say they are. Frankly, whether or not they're cloning their voice, but you need to clone your voice to get through the biometrics in the first place. So it's always this kind of there's this constant tussle between the fraudster and the person being scammed. And big corporations can afford to invest in this type of technology. Unfortunately, and we know this because of the amount of people who are being scammed on all sorts of things all the time, you and I, on a personal level, can't. So, that is another, it's kind of a topic for a whole other podcast in a way, is, how is it that big tech can protect themselves and big companies protect themselves, but leave the rest of us out there bobbing on the sea and get taken out by fraudsters. But it is a very real issue that fraud is advancing to such sophisticated state now, and things like deepfake audio and deepfake video are really playing their part in that.
And just a quick word from our sponsors. ConfigCat is a feature flag service. Easily use flags in your code with ConfigCat libraries for Python and 9 other platforms. Toggle your feature flags visually on the visual dashboard. Hide or expose features in your application without redeploying code. Set targeting rules to allow you to control who has access to new features. Config Cat allows you to get features out faster, test in production, and do easy rollbacks. With Config Cat's simple API and clear documentation, you'll have your initial proof of concept up and running in minutes. Train new team members in minutes also, and you don't pay any extra for team sizes. With a simple UI, the whole team can use it effectively. Whether you're an individual or team, you can try it out with their forever free plan. Release features faster with less risk with Config Cat. Check them out today at configcat.com. So, at the very start of the show, I gave everyone a mini existential crisis. Now we've scared the pants off them with how much of a real threat deepfakes are. Are there any benefits to it apart from, wasn't that cool because I saw Johnny Depp sat in my front room, or I made myself look like the guy from Vikings? I'm not saying I've done any of those, but those things are cool toys. Is there any real benefit to it? Is there something that we're going to be like, wow, this changed my life?
There's quite a lot, actually. And I think, like all technologies, it works in both directions. There's some really great work being done, actually, for people who are losing their voice for one reason or another. So one of my uncles had motor neuron disease, and it's a ghastly degenerative disease. And to see people, they lose the ability to speak, to breathe. It's a terrible thing. But there is work being done now to help people preserve their voice, and the same for people who've got other degenerative conditions. So actually, you can keep your voice, and as you deteriorate, you're still able to communicate. And we all think about Stephen Hawking and his robot voice, but that became his voice. Actually, that synthesizer was replaced and updated many times over the years, but he was offered new voices, but he chose to keep that original robot voice that then had to be synthesized to sound like something that's ridiculous, because that was his voice. And that's what, and so that sort of work is incredible. I think that that's a wonderful use for it. We were talking before the show about, kids not being able to meet grandparents and great grandparents. It's one thing to, I've got a lot of pictures of old ladies in, just kind of in blurry photos, and it's and I've got no idea who these people are. And yes, it's a little bit different today because we're able to store some of that in a way that we weren't able to before. You can take a video of someone, but actually to be able to hear them express things, we can begin to bring people back to life. It's a kind of, it's like a very cheap version of cryogenics, really, that we can actually recreate that. In the medical context, I mean, there's a whole bunch of things. So one of the biggest problems of technology that's coming out of gaming. So avatars have obviously been a big thing in gaming for a long time, but we've seen them creep into the non-gaming world for chatbot type applications, and people want to use them for medical and mental health and this type of stuff. So you can speak to an avatar, and there's something called the uncanny valley, and the uncanny valley is the bit between something which is computer generated, which is clearly fake and is totally photorealistic. And you think about, I'm not a big player of computer games, but I do know certain members of my family who are, and I can remember, watching FIFA and this sort of stuff. And you've got these, there's a footballer, and it looks uncannily like them, but it clearly isn't. That's what the uncanny valley is. It's something computer generated which is so almost perfect but isn't quite right. And that is the, so imagine that I'm speaking to a teledoctor, and I want to feel comfortable, or a telecounselor, and I'm doing some form of online, and we're going to see a lot of health delivery being done in an automated fashion in the next 10 years or so, as natural language processing systems get better, as conversational AI gets better. A lot of these things will be able to be done that way. But I want to interact with someone who feels familiar. Current avatar technology would frankly scare the hell out of me. I'd be speaking to someone who looks so perfect that they were clearly not real. And so what deepfake technology will enable us to do is to say, give me the doctor that I feel comfortable with, sounding like the doctor I feel comfortable with, and then I'll actually be able to interact with them. Not, or maybe I might choose James Mason because he sounds, mellifluous or something like that. But the point is, we'll be able to interact with people in a much more naturalistic way, in what is effectively a completely faked up way. Or,
Yeah.
say a podcast, for example. So say, for example, that, today I'd accidentally double booked. I'm supposed to be watching my favorite football team play their biggest match of the entire season. And let's say you were supposed to be out with a friend and you completely messed it up. One of us would have sent our avatar in to go and talk to the other one's avatar. And I mean, I'm not necessarily advocating that we go around faking podcasts all the time, but a lot of content can be generated for people who feel uncomfortable with it. You and I, clearly, we're very happy to sit here and talk on this sort of thing, but there's a whole bunch of people out there who actually have a lot to say but are far too shy to say it. And you're never going to get them speaking publicly, but actually you want to hear what they've got to say. So actually using this type of technology gives a voice to people who don't otherwise have a voice. So there's an enormously wide range of things that we can use it positively, but inevitably, like almost all technology, where there's a positive side, there's a very negative side that goes with it. And we have to be very careful to we have to develop techniques to detect things which are clearly fake and stamp down on them very quickly. Removing, deepfake pornography, to deal with voice spoofing. All of these types of things to try and allow this other part of the market to blossom.
Yeah, just to jump back to something that you said there about conversing with a computer-generated person about mental health and things like that in the future. I don't know if you've had chance to play with Epic's Metahuman on the Unreal Engine, but it seems like it's a precursor to I don't know if you've read the book and seen the film Ready Player One and Ready Player Two.
Yes, indeed, yeah.
So they've got these universes, and I would imagine a great deal of our listeners will have seen the films and read the books where your avatar is walking around. And this thing from Epic, it seems like a precursor for that. You're generating photorealistic looking people, in this application. And this is all in real time in the browser. And I looked at it, and like you were saying about FIFA, you're looking at these guys running around a field, and they are quite obviously digital. They're digitally created. They also look very real. Now, that's the thing I got from Epic when I was looking at this Metahuman. It looked too perfect. But then I changed the lighting. It has a couple of different lighting settings. I was able to set it to outside lighting. And it was a bit like in a lot of the older 3D films like Toy Story, where you looked at things. I think Monsters Inc. was a good example of it. That the 3D models, they were very good and they looked like 3D models. I think there's one point where Sully gets very wet and all of a sudden he looks very real because of the dynamics of the way the light shines off the wet fur and things. It just sort of upped it a little bit, and changing the lighting on the avatar that's been created to being outside, you had that sunlight. So you had 56,000 Kelvin lighting on it rather than that flat white light. It changed it completely, and it suddenly looked real. And I was like, this is really cool. And I played around with it for about 45 minutes trying to make myself, and I got pretty close. But I think some of the data that they've got for the models is slightly swayed to one group of people. And I couldn't get away from making myself look some sort of Asian or Mongol type face. No matter what I did to it, it looked slightly Asian, and I was like, I know I don't look Asian, and I'm tweaking these things, but it's a very early beta that's out there at the moment. It's very, very impressive, and anyone that hasn't had a go and have a go at that. But if you mix that with the deep fake voice, you're more than halfway there with it to get that presence.
Yeah, I mean, and it's going to help with things like video conferencing. So, one of the problems with video conferencing at the moment is the fact that it does use up a massive amount of bandwidth. So, the audio portion is really tiny, but the video portion is really large. And actually, NVIDIA have just released some really interesting technology around this, which effectively can take your face and re-render it at the other end, but literally there is no video sent. All they're sending is the features of your face, and it's a very analogous to deepfake technology. So rather than transforming you into someone else at the other end, they transform you into yourself at the other end. Yeah. And they reckon that there's something like a 97% reduction in data which is being sent. That's really impressive.
Yeah.
And you could do the same with audio. So, there are large parts of the world where bandwidth is still very low or very expensive. So rather than sending the full audio, what you do is you send the text, and because if you think the phone can be quite powerful, but there's my watch being very powerful in the background there. But the phone can be quite powerful and do speech. I'm going to, excuse me while I just throw my my watch away. It's one of the problems about working in the speech recognition world is I have to have everything switched on for speech recognition all the time, and unfortunately, it does it at very random moments. But actually, the point being there that the device is good enough to do speech recognition, but the bandwidth to connect to the next device is very low. So I can speak, turn it into text with a little bit of prosody attached to it, just so there's some understanding of what I sounded like, and then resynthesize me perfectly at the other end.
Yeah.
So there's all sorts of ways in which we can use deep fake. I mean, and that's where you want to kind of, it's very pejorative, this phrase deep fake. It sounds, it sounds great, deep fake, but it's not just about that. It's about very clever ways of doing compression and representation of stuff. And so, for those of us who are actually involved in coding and programming, it's a very interesting new way of thinking about compression technology. So, what anyone who knows anything about voice compression, so voice compression used to be about if you're trying to transmit a voice from one place to another and you want it to transmit less data, the way you did it was by taking things out. So, if you had 16 kilohertz audio, you'd reduce it to 8 kilohertz. There you go. You've taken out half the data already. You'd reduce the frame rate from it. That's how you compressed audio. But in the 1980s, when mobile phones first came out, the GSM codec that was used, so the GSM obviously being the thing we talk about for the technology, but actually there is an audio codec called GSM, which is how this stuff was transmitted, was a form of resynthesis. So actually, it wasn't just about taking things out to compress it. It was literally about saying, we're only going to send some of the data, and the rest of it, when it gets to the other end, we're going to resynthesize from what was literally a code book. It was literally, right, okay, that was number 37, so make the sound number 37 at the same time as the sound number 39. And it's one of the reasons why GSM for those people who are involved in this will know that there's not very much noise in the background of it, because noise wasn't in the code book. Voice was in the code book. So don't try singing down a mobile phone, because it just wasn't really set up for music and for voice. So, so actually, as compression technology, this is really interesting. To re-render something completely in a completely photorealistic or audio realistic way at the other end, as we go forward, is going to be really interesting, because look at WebRTC. So anyone who's done anything around gaming, around podcasting, anything, will have some understanding of WebRTC. But for those who aren't totally familiar with it, traditional telecoms and so on relies upon the fact that I pass my data through somewhere central to get to where it needs to go. So if I'm phoning you, my phone connects to a telephone exchange, for want of a better word, and then it goes through another wire, and then it passes kind of all the way through the central system and it ends up at you. When I make a mobile phone call, it starts off, it hits the mast of the operator, it goes back into their core network, and then is sent out again. That's completely reliant on a central operator having effectively like a massive server in the middle to send all this data through. WebRTC was a way of getting around that to actually send data peer-to-peer. So most video conferencing now, the audio and video is sent directly from your computer to the computer of the person who's receiving it. And the only thing which goes through a server is the signaling piece, which effectively says, Nigel, tell me where James's computer is. Right, James's computer says, right, I'm over here. Great, you two go talk to each other.
And you get that private tunnel between the two, then.
Yeah, but something like 5 to 10% of all traffic can't be sent like that. So you use a central server, something called a turn server, which sits in the middle and acts as a conduit for that traffic. Now, if you're Zoom, you can afford to set one of these things up. If you're Microsoft, you can afford to set one of these things up. But actually, for most people, the bandwidth cost involved in setting up one of these things is, I think Twilio charged 60 cents a gigabyte. Well, it doesn't take too many hours worth of video conferencing to use up 60 cents, So if you could actually reduce that to a 10th or a 100th of it, suddenly WebRTC, really democratized video conferencing and really democratized broadcasting, comes within the reach of ordinary people, and we become a lot less reliant on the big players. So again, there's so many ways in which this technology can be used, and reducing bandwidth, to me, is actually the most exciting part of the technology, if not the sexiest. But for those of us who are actually down there in the weeds worrying about how much it costs for every gigabyte we send, it becomes a lot more interesting.
Yeah, it definitely does. As you say, it's a very scary prospect, all the deep fake stuff. But for things like that, reducing the costs of actual video conferencing, getting better video quality to the consumer is fantastic, and I think it'd be great to get to that point where we're seeing that every day, because there's a lot of services out there that are really failing. I think on the audio and the video conferencing, and with the situation that is currently going on globally, it's really brought that to the forefront of everybody's mind, because everybody now, even like my parents and grandparents and things like that, they'll know what Zoom is. Yep. Whereas 18 months ago, they would have thought that was when you go really quick in a car.
It's on a camera.
So, yeah. So it's very pertinent, and it's something that as you say, the people like Zoom and that, their video conferencing is great. It doesn't tend to be very. You don't tend to get a lot of loss, but unlike the service that we use for recording, that at several points has lost the video and a couple of points lost the audio as we've been recording. But due to the way it records, hopefully we should all be okay. They're losing out. But if we deep faked some of this, it would have been perfect at both ends,
and a lot funnier probably as well.
Yeah. yeah.
Let's redo that joke. No, scrub that.
We'll have some AI telling us whether that was a funny enough joke.
Exactly.
Yeah. And I think we could probably talk about this forever and a day. There's so many topics that we could deep dive into on it. It's fascinating. But as a few last pearls of wisdom for the developers out there that are listening and are concerned about deepfake, is there anything that they could do right now? Is there anywhere they could go to start learning about this, to start combating possible issues that they may come across in their career because of it?
I think at the moment you have to think about it as much as a human being, as a developer, because the biggest threat to developers is AI that can develop, rather than just, so we're going to have deepfake developers before long.
I think I've worked with some of those. They're not very good at the
moment. I've just worked with a lot of fake ones, let alone deepfake ones. But it is very much about being on your guard against the type of scams that will come out through this, because we can see it in recruitment, for example. So imagine if you got a phone call as a consultant for someone who was purporting to be the HR director of a well-known place, or the MD, and they phone you up and say, I've got this super secret urgent job that I need you to do, and I'm trusting you to do it. As a sign of good faith and understanding, I need you to send £1,000 to me. This is a deposit, just to show that because this is highly confidential, and to secure the non-disclosure agreement, you need to do that. But clearly, once you've signed that, because it's only a legal thing, nothing more than that, then I'm going to pay you 50 grand for this work or whatever. I'm just hypothesizing here, but the point is, it's very easy to be scammed by this stuff. So, ask questions. If you get a phone call which purports to be from someone like that, say, I'll call you back on the switchboard. It doesn't matter what it is. Just make sure that you do that, and don't rely on, if someone tells you that they're giving you something to work with, and it's going to use biometric authentication, right? So too many programmers just kind of slavishly do what they're told, and a good programmer takes a step back and understands the context that they're working within. So if you're told by your boss that we're going to use biometric authentication to do this, take a step back and ask them, well, is that going to be single factor or not? Because single factor biometric authentication is pants, frankly. It's, as we said before, with the face, with family members and that type of stuff. How many factors of authentication are you going to use for it? What are those other factors of authentication? Where else are we going to do it? You're going to do text messaging as well. Okay, well that can be spoofed, so let's not do that. So just I think, like everything, be aware of the limitations of the technology. Understand what it can do, understand what it can't do. So using any popular search engine, go out and investigate deepfake technology. Honestly, if you just Google deepfake technology, there's a whole load of stuff. Look into Tachytron 2, which is one of the most advanced generative networks. Waveglow is another one. All of these things will give you some really interesting insights into how to build these things, how to work with them, and if you start to take that approach, you'll get some really interesting insights into what can be done with this, and just stay on the alert.
Fantastic. Yeah, I think with the scams and stuff like that, asking those questions, it will become second nature to the more tech savvy like we have at the moment, where if you get an email, you'll look at where did that email come from? You would then maybe even look at the trace that you can get from the email headers. If there's a website, you'd go and look at the domain. So I think it'll just become second nature eventually, but it's not quite there yet. But it's been really interesting having you on, talking about this topic. It's fascinating. It is fascinating. And it's probably an edge of technology that I would say the majority of our listeners have not thought about with regards to their job. But it is something that's going to be coming to all your enterprise applications through authentication and things like that we've talked about. So it is something you need to be aware of. So that sort of leaves me with just to say thank you for spending the time. Thank you for missing your football match to be on and record with me.
Thank you for having me. I haven't looked at the score yet, so I hope I'm still happy when I get off the podcast. But thank you so much for having me.
Yeah, not a problem. Football was a swear word in my house growing up, so it's something I've never really got into. But I hope your team did well. And thank you to everyone out there for continuing to support the show. I'm James Stoddart, and you've been listening to Nigel Cannings talking about deepfakes. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help The Cynical Developer to reach more developers around the globe.